All right, hey everyone. I'm just wanted to go over a couple of different examples of how to go from a table of values to find an equation, and then you can actually use that equation to predict later values in the table. All right, sorry, I forgot how to speak English for a second. All right, so the basic form for an equation, all right, is y equals something times x plus something. All right, that's the basic format. All right, now these letters will change depending on the table of values themselves. So for this one down here, it would be v equals something times a plus something. You might be like, well, why has he done it that way around? Well, the idea being that the a is the one that's counting up by ones, therefore it's the variable that we want to work with in the equation. You could do it the other way, but it's going to be much harder. So you always want to have the it's called like a reactive variable. And anyway, I'm not going to bore you to death with the reason why, but generally speaking, the one that follows the linear numbers 1, 2, 3, 4, 5, 6, that's the one you want to have in your equation. Right? Your answer should be the other value here, so the b. And then in the last one, again, I'm following a similar fashion. Instead of a and b, just to show you it can be anything, we've got a square and a triangle. So the triangle, the value of the triangle equals, this is where choosing squares for the previous things is not ideal, but something times whatever the square value is plus something, right? And we're just going to fill in these gaps. You might be looking at it, well, how do we fill in these gaps? Well, basically, there are a couple of ways you can go about it, right? Firstly, when you have a table, you should generally see that there's a pattern along the top, right, being 0, 1, 2, 3, 4, right? So as this is increasing by 1, right, the bottom is increasing by 2, in this case anyway, right? And what this increase by 2 indicates for us is that essentially every time this x value goes up by 1, the whole answer goes up by 2. That actually tells us that this number multiplied by that x has to be 2, right? So I should get y equals 2 times x plus something, right? And that's only because if this goes up 1, this x goes up 1, the whole answer is going up 2, therefore I'm multiplying it by an extra 1. It might be a little bit confusing to think of, but basically all you need to think of is whatever this constant pattern flowing through here is, right? So all the way through here it's positive 2. That's your number that is multiplying the x, right? Or the a or the square or whatever you're using. Whatever this number is here that increases by, or whatever the pattern is, that's what you want to put here. Now, there's a couple of different ways to solve for this last number, and I'm going to do an example of all three for each of these equations. So it's going to be a different way each time, and you can pick whichever way you like the most. They'll work regardless of which one you do. Right? So the first one is nice and simple. All right. Whatever this value on the end is here, right? If I have this point here where x is equal to 0 and y is equal to 5, what that tells me is 2 times 0 plus something equals 5. Yeah, that's what y is when x is equal to 0. So 2 times 0 plus something equals 5. 2 times 0 is 0. 0 plus 5 gives me 5. Therefore, this has to be 5, right? So I've got y equals 2 times x plus 5. Now if we go back here, we can check it for all these values and see if it makes sense. So 2 times 0 is 0, plus 5 equals 5. That's good. 2 times 1 would be 2, plus 5 would equal 7. 2 times 2 would equal 4, plus 5 would equal 9, right? You can see how that works with every single number there. So for every single, spot in this table of values, 2 times whatever the x value is plus 5 will give you the y value. That's what we're figuring out here. So let's do the same thing below, but with a and b. So again, I want to find this number first. This is my pattern number. So whatever this is going up by. All right. So that's going up by 3s this time, meaning that every time a goes up by 1, it goes up by 3. Or the whole answer goes up by 3. Therefore, it is 3 times a plus something will give us b. All right. So that's fine. We can do something with this. There are a couple of ways you can work this out. And what I want to do is I want to pretend there's an extra box back here. All right. So I'm just adding a box onto the end. And as you can see, our top is going up by 1, right? The whole way up. Now we don't have 0 to do the way that we did it previously, but there's no reason why we can't do that. So let's work backwards, right? So from here, we would plus 1 onto 0 to get 1. And we would plus 3 onto whatever this is to get 5. So this plus 3 equals 5. So in this case, if I want to find something plus 3 equals 5, it's the same as 5 subtract 3, which gives me 2 in this case, right? So then I can work it out the exact same way as before, because I know when a is equal to 0, it's 3 times 0, plus 2 gives me 2. So I can say that it's 3 times a plus 2. Right, so whatever correlates to this 0 value is whatever this number is on the end, the constant. And there's one last way to do it, and I actually find this the most satisfying way to do it. However, some people don't like it, and that's fair enough, because it's a bit, it takes a bit of working out. And I've also added on this one a blank box on the end, and we're going to use our equation at the end to predict what the square value is when our triangle equals 42. All right, so similar to before, I'm going to get my pattern. All right, so my pattern across the bottom here is going up by 4, which means it's 4 times whatever my square value is will equal my triangle, or plus something will equal my triangle value, I should say. So 4 times square plus something equals triangle. Now, we don't have a 0. We could do what we did before, but I want to do it in a different way instead. What I want to do is I want to pick a random point from here. So let's say I'm going to pick, I'll pick 2 and 6. It doesn't matter which one you pick, because it'll all work out the same, right? And what I'm going to do is I'm actually going to substitute these values in here and find this unknown number here. So I'm going to change this so it's triangle equals 4 plus square, 4 times square plus, I'm just going to call this, I'll make it a circle for now, right? Because I don't know what that value is, but I do know that these values, the square and the triangle, right? So I can say the triangle equals 6 in this one point here, and it's 4 times whatever square is, which is 2. So 6 equals 4 times 2 plus whatever the circle is. So that's the same way as saying 6 equals 8 plus whatever the circle is. Okay? I've got to think and I shouldn't have picked the circle, because now in hindsight it looks like a 0. So I'm just gonna quickly change this from circle to be, I'm just gonna make it y. Alright? Because otherwise it's going to look like 0. It's going to confuse you. All right, so 6 equals a plus whatever y is. Okay. How do we get, if we're plussing, how do we get lower than what 8 is? All right. Well, the answer is we plus a negative number. Well, what negative number? So 6 equals 8 plus something. Well, the way of figuring this out is I can actually minus 8 from both sides. Alright, if I subtract 8 away from both sides, so that should be 6 minus 8, not 8 minus 6. I get negative 2, and 8 and 8 cancel each other out. So our y value, or our unknown value in this case, is equal to negative 2. So I go back to this original equation, and I have triangle equals 4 times whatever the square value is, plus negative 2. Or a better way to put it is triangle equals 4 times whatever our square value is, minus 2. And you'll see that works the whole way along here. So 4 times 2 minus 2 gives you 6. 4 times 3 is 12, minus 2 gives you 10. And so on. That'll work with every number here. But then the question is, what's this unknown number? We don't know what the top one is. We know the triangle value is 42. We have 4 times square minus 2 gives us 42. All right? And this is a solving problem, but essentially if I want to get this, and we'll go through this in future classes, but if I want to find out what this unknown number is, I've got to think of 4 times something minus 2 gives me that. It's the same way of saying 4 times something equals 44, right? Because I'm not subtracting 2 anymore. So I know that just this bit equals 4 times something. Right? And that something, in this case, is 11. Because 4 times 11 gives me 44. Right? You could do a division and break it down through division and stuff like that, but we're going to do that in later classes. I just wanted to give you a bit of perspective on how some of this works. So I don't know which one of these methods you prefer, but all I want you to be doing is to follow these rules and choose one of these formats to calculate this rule. All right. Hopefully that didn't confuse you too much. Enjoy the rest of the day.